So, let's go. The universe is 13.8 billion years old, but it's 93 billion light years wide. That's not a typo. That's not a rounding error. And the reason why is going to unravel everything you think you know about space, time, and the word distance. 10 facts. All of them real. All of them wrong in ways you didn't expect. Number 1. The universe is bigger than its own age should allow. You've probably heard that the universe is 13.8 billion years old. And you probably assumed that means we can see 13.8 billion light years in any direction. That's how light works, right? You can only see as far as light has had time to travel. Except the universe doesn't care what you assumed. The observable universe stretches 46 billion light years in every direction. That's a diameter of 93 billion light years. The universe is older than it is wide only if you think of distance as fixed. It's not. Here's the thing. Space itself is expanding, not galaxies flying through space like shrapnel from an explosion. The space between them is stretching, the gap is growing, and that growth has no speed limit. Einstein said nothing can travel faster than light through space. He said nothing about space itself. So imagine you're rolling a ball toward a friend. Simple. But now imagine the floor between you is a rubber sheet, and someone is slowly pulling both ends. Your ball is still moving at the same speed. But by the time it gets there, your friend is much further away than when you threw it. That's what the light from distant galaxies is doing. It left its source 13.8 billion years ago and traveled the whole time. But the source kept moving, carried by expanding space. The ancient light from the edge of what we can see was emitted from something that is now 46 billion light years away. Every distance number you're about to hear works like this. The universe isn't a snapshot, it's a process. And that process has been running longer and stranger than the numbers suggest. Number 2, you are always watching the past. And the further you look, the older the past gets. Right now, if you step outside and look up at the sun, you are not seeing the sun. You are seeing the sun as it was 8 minutes and 20 seconds ago. That's how long its light took to reach you. If the sun vanished right now, you wouldn't know for 8 minutes. Look further. The Andromeda Galaxy, the faint smudge you can just see with your naked eye on a dark night, that smudge is 2.5 million years old. You are seeing that galaxy as it existed before modern humans walked the Earth. Before language, before fire, before almost everything. Now aim a telescope at the most distant light in the universe, the cosmic microwave background. This faint cold glow fills the entire sky in every direction. It is not light from a star or a galaxy. It is the afterglow of the Big Bang itself, the oldest light that can exist. And it left its source 380,000 years after the universe began. Before that point, the universe was a dense, opaque plasma. No light could travel through it at all. The CMB is literally the moment the universe became transparent. It's the fog lifting. Before it, a wall. The universe has a visual horizon, and we are living at the center of it. But here's the part that should keep you up at night. Between that first light and the first stars, there was nothing. No light anywhere. Just hydrogen, helium, and the slow gravitational pull of dark matter clumping in the dark, building the scaffolding of everything that would come later. For hundreds of millions of years, the universe sat in total darkness and grew. Then the first stars ignited. And the lights came on. And we have never directly seen those first stars. Not once, not yet. Number 3, the most distant thing we've ever seen shouldn't exist. In 2025, astronomers aimed the James Webb Space Telescope at what looked like an empty patch of sky. They were specifically hunting for galaxies that seemed too good to be true. They named the survey Mirage, or Miracle. You can already tell where this is going. They found one, a galaxy called MOM-Z14, and when they confirmed what they were looking at, the number they got back was a redshift of 14.44. That number means you are seeing this galaxy as it was 280 million years after the Big Bang. 2% of the universe's current age, a cosmic infant. Here's why that breaks things. The light from MOM-Z14 has been stretched so severely by expanding space that it arrives 15 times longer in wavelength than when it left. What started as ultraviolet radiation arrives as infrared. You couldn't see it with your eyes. The universe has stretched it into a completely different kind of light. And the galaxy itself is tiny, about 241 light-years across. The Milky Way is 53,000 light-years wide. MOM-Z14 is 1% of that size, but it is shockingly, inexplicably bright. Too massive. Too chemically complex. Too developed for something that young. In 2022, before Webb turned on, we had exactly one confirmed galaxy from the universe's first 500 million years. One. Now we have hundreds. And they keep showing up brighter and more developed than everything we thought we knew about how galaxies form. The lead researcher on MOM-Z14 wrote that the telescope was pushing toward previously unimaginable redshifts. The word unimaginable is in an actual scientific paper. That's the state of things. Something built galaxies faster than physics said it could. We don't fully know how, and Webb is still looking. Number 4. The universe has a shape and most of it is nothing. Zoom out, far out, past galaxies, past clusters of galaxies, past superclusters, all the way to the scale where the entire observable universe fits in one frame. What do you see? Not a cloud of galaxies scattered evenly through space. Not a smooth glow of matter. You see a web. A vast three-dimensional foam of bright threads and enormous dark bubbles. Scientists call it the cosmic web, and it looks almost unsettlingly like a neuron under a microscope. The bright threads are filaments, highways of dark matter and gas, hundreds of millions of light-years long, along which galaxies cluster and flow. The dark bubbles are voids, regions of space so empty that a cubic meter might contain 1 or 2 hydrogen atoms. That's it. The Buta's Void is the most famous of them. Discovered in 1981 and nicknamed the Great Nothing, it stretches somewhere around 330 million light-years across. It contains about 60 galaxies. In a region that size, you'd expect around 2,000. If the Milky Way sat at the center of the Buta's Void, we might not have discovered that other galaxies existed at all until we built the instruments we have today. The largest confirmed physical structure in the universe is a filament called Quipu, about 1.3 billion light-years long. There may be something bigger. A possible structure called the Hercules Corona Borealis Great Wall stretches potentially 9.8 billion light-years, close to 10% of the observable universe's diameter. But it's disputed. Scientists are still fighting over whether it's one structure or just a coincidence of alignment. What isn't disputed, the voids win. The vast majority of the universe's volume is occupied by almost nothing. The matter, the galaxies, the stars, the planets, all of that exists in thin threads around the edges of enormous emptiness. You, and everything you've ever known, live in the foam on the surface of an inconceivable amount of nothing. Number 5, neutron stars, scale attacks from the other direction. Everything so far has been about how vast the universe is. Let's go the other way. A neutron star is what's left after a massive star dies. The core collapses so violently that electrons and protons fuse together into neutrons. What's left is a sphere about 10 to 15 kilometers across. Smaller than a city, you could drive across it in about 10 minutes. It contains 1.4 times the mass of the Sun, 300,000 times the mass of the Earth, compressed into something the size of London. 1 teaspoon of neutron star material weighs roughly 5.5 trillion kilograms. That's about 900 times the mass of the Great Pyramid of Giza in a teaspoon. If you somehow brought that teaspoon to Earth and the gravitational pressure holding it together suddenly vanished, it would expand explosively. Not like a grenade, like a small nuclear event. The neutrons would decay, the energy would release, and you would have much bigger problems than a spilled teaspoon. The fastest spinning neutron star we've found rotates 716 times per second. Its equator is moving at 24% the speed of light. It is spinning so fast that if it were any more massive, it would tear itself apart. And it just keeps going. And then there are magnetars. A magnetar is a neutron star with a magnetic field so extreme it can affect atomic structure from 150,000 kilometers away. In 2004, one magnetar released a burst of energy so powerful that in 1/10 of a second, it put out more energy than our sun has released in the last 100,000 years. We detected it from 50,000 light years away. It was still the brightest thing ever seen from outside our solar system. The universe's most violent physics is happening inside something you could fit inside a medium-sized city. The universe doesn't scale politely. Number 6. Almost everything is nothing. Here is something true about you. You are 99.9999999% empty space. Every atom in your body is almost entirely void. If you took a hydrogen atom and scaled it up until its nucleus was the size of a marble sitting at the center of a football stadium, the electron would be orbiting somewhere in the upper bleachers. Everything between the marble and the stands is nothing, just electromagnetic force holding the illusion of solidity together. When you touch a table, you don't actually touch it. The atoms in your hand never make contact with the atoms in the table. What you feel is the electromagnetic repulsion between electron clouds, two fields of nothing, pushing against each other. Your entire physical experience of reality is force, not matter. If you removed all the empty space from every human being who has ever lived, the remaining mass would fit inside a sugar cube. Now, scale that up. The average density of the entire observable universe is about 5 hydrogen atoms per cubic meter. That's less than the best vacuum humans have ever manufactured in a laboratory. The entire universe, on average, is emptier than anything we've been able to create on Earth, and of the matter that does exist, only about 4.8% of the universe is the ordinary stuff. Atoms, molecules, the periodic table, you. The rest is dark matter and dark energy, neither of which we have ever directly detected or held or seen. Of that 4.8%, most is diffuse gas floating in the space between galaxies. Stars and planets make up about 0.3% of everything. You are a rounding error, inside a rounding error, inside an almost perfect vacuum. Number 7. The numbers themselves break. At some point, the scale gets so large that comparison stops working. Let's find that point. There are roughly 10 to the power of 24 stars in the observable universe. That's 1 septillion. Written out, it's a 1 followed by 24 zeros. There are approximately 7.5 times 10 to the power of 18 grains of sand on every beach and desert on Earth. The number of stars beats the number of sand grains by a factor of roughly 100,000. The universe has 100,000 times more stars than Earth has grains of sand. Every grain of sand you've ever seen or touched represents 100,000 suns. There are approximately 10 to the power of 80 atoms in the observable universe. The Eddington number, named after the physicist who first tried to estimate it, 10 to the 80. Written out, it's a 1 followed by 80 zeros. Here's where the comparison breaks. The number of possible chess games, all the legal moves, all the variations, all the ways a game of chess could unfold from first move to last, that number is larger. Roughly 10 to the power of 120. There are more ways to play a game of chess than there are atoms in the observable universe. The universe is vast. But the space of possibilities is vaster. And somewhere in those numbers, human intuition just gives up. You can say 10 to the 80, you can write it down, but you cannot feel it. The number has left the territory of meaning and entered the territory of symbols. And we're not done yet. Number 8, the universe is expanding faster than light. And we can't agree on how fast. Everything is moving away from everything else. Not because of some explosion pushing things outward, but because space itself is growing between them. The further something is, the faster it recedes. And past a certain distance, roughly 13.8 billion light years, galaxies are receding from us faster than the speed of light. Not moving through space faster than light. The space between us and them is growing faster than light can cross it. This was confirmed in 1998 by 2 separate teams of astronomers studying exploding stars. They expected the expansion to be slowing down. Gravity should be pulling everything back. Instead, the expansion was accelerating. Whatever is driving it, and we call it dark energy because we don't have a better name, makes up 69% of everything in the universe. We have never detected it directly. We only know it's there because of what it does. Now here's the part that should make you uncomfortable. We have 2 precise, careful, independent measurements of how fast the universe is expanding. One uses the CMB, The ancient light from the early universe, it gives 67.4 kilometers per second per megaparsec. The other uses Cepheid variable stars and exploding supernovae in our local cosmic neighborhood. It gives 73 kilometers per second per megaparsec. Those numbers disagree by 9%. The gap has 5 sigma statistical significance, which means the odds of it being random noise are less than 1 in 3.5 million. At the American Astronomical Society's January 2025 meeting, a cosmologist stood up and said, "This is a crisis, not a puzzle, not a tension, a crisis. Because if both measurements are right, something is wrong with our model of the universe at a fundamental level." The James Webb Space Telescope was specifically used to check whether the local measurement was wrong. It wasn't. The crisis deepened. We know the universe is expanding. We know it's accelerating. We don't fully understand what's driving it, and now we can't agree on the rate. The video stopped being a tour of how big things are and became something else. Number 9, we are losing the universe in real time. Due to accelerating expansion, there is a maximum distance from which light will ever reach us, even given infinite time. That boundary sits at roughly 62 billion light years. Beyond it, no signal, no photon, no information of any kind will ever arrive. Not in a billion years. Not in a trillion. Not ever. And it gets worse. In approximately 100 billion years, every galaxy outside our local group will have vanished from view. Not destroyed, just gone, carried beyond the event horizon by expansion, their light redshifted into wavelengths so long they become undetectable. The sky will look dark. A civilization living then will see a small island of galaxies, will have no way of knowing the cosmic web ever existed, and will likely conclude the universe is small, static, and lonely. They will be completely wrong. But they will have no way to know that. We live in a specific window of cosmic history. Early enough that the full web is still visible. Late enough that we have the tools to see it. A few tens of billions of years in either direction, and this entire video couldn't be made because the evidence would either not yet exist or already be gone. You are watching the universe during its brief visible era. It is, as far as the evidence can tell you, the only time this view will ever be available to anyone. Number 10. The observable universe is probably the smallest thing we'd ever call the universe. Everything in this video, every galaxy, every void, every neutron star, every CMB photon, every number that broke your intuition, fits inside a sphere 93 billion light years wide. And that sphere is almost certainly not the universe. No model of physics proposes a wall, an edge, or a boundary. The universe may be infinite. If the theory of inflation is correct and the evidence strongly supports it, then the universe expanded so rapidly in its first fractions of a second that the total size of everything dwarfs our observable bubble by at least 10 to the power of 23. That's the conservative estimate. Some models put it so much larger that the number has no useful analogy. Everything we've described, every fact that broke you, exists in a region that is, by the math, cosmically unremarkable. A single rounding error in the full ledger of what exists. This is where the hard science ends and honest speculation begins. What's out there beyond the horizon is, strictly speaking, unknowable. Not just unknown. Unknowable. No signal can reach us from it. No observation can confirm it. What we have is math that points in that direction and physicists who take it seriously. The inflationary multiverse, the idea that our universe is one bubble among an unknowable number of others, each with potentially different physics, different constants, different histories, is a legitimate scientific hypothesis. It is not confirmed. It may never be confirmable. But it is what the equations allow. And the people who write those equations find it plausible. Which means the 93 billion light-year sphere that took 10 facts to begin to describe might be the smallest meaningful unit of universe there is. A grain of sand on a beach that has no edges. In a desert we will never see the end of, with no map. And no reason to think the desert cares that you're in it. That's where we are. Not at the end of the answer, at the edge of the question. And here's the thing nobody tells you when they hand you these numbers. The universe being this big doesn't make you small in a way that should depress you. It makes you improbable in a way that should terrify and astonish you in equal measure. Because somewhere in a cosmos that is mostly vacuum, mostly dark, mostly nothing, on a thin thread of a filament, in a galaxy that is one of at least a trillion. Orbiting a completely average star on a rock that is statistically absurd, you exist. You are made of atoms forged in dying stars. You are the universe looking at itself. And somehow, against odds that have no meaningful expression in any number system we possess, you are conscious enough to be confused by it. The Buddha's void doesn't know it's empty. The neutron star doesn't know it's spinning. The filaments of the cosmic web aren't aware they look like neurons. But you watched this video. You held these numbers in your head and felt something. Maybe vertigo, maybe wonder, maybe the specific kind of existential nausea that only comes from thinking too hard about the word infinite. That feeling. That is the only thing in the observable universe we know for certain is actually here. Everything else is light that left somewhere long ago, stretched and cold, arriving late to tell you about a place that has already moved on. But that feeling is live. Present tense. Happening now. In a universe that is still expanding, still accelerating, still building structures we don't have names for yet. In a darkness we will never fully light. We built better telescopes and found more universe. We will build better ones still and find more after that. Every time we look deeper, the answer gets larger and the question gets stranger. And that's not a failure of science. That is science working exactly as it should in a universe that is apparently committed to being more than we can hold. You came here for 10 facts. What you got was the beginning of a much longer confusion. Welcome to it.